Here's problem 14, and I'm going to look at two ways of solving this. It says triangle ABC is congruent to triangle XYZ. It then tells me AB's length, BC's, and AC's, and then it says, well, if that equals 2n minus 1, what is the value of n? Well, the typical way most of you are going to do, you're going to say, hey, I got triangle A, BC, and it's congruent to triangle X. And again, since I went ABC, the X has to match the A. The Y has to match where the B is, so I'll put the Y here, and the Z has to match up with angle C there, where C is, so this is going to be Z. Now it tells me, let's fill in, AB is 8. Well, if this is 8, what does XY have to be? Since they're congruent, it means they're the same length. That's its corresponding side. AB corresponds to XY, so it has to be 8. BC is 10, so if that's 10, this has to be 10. If AC, A to C is 11, then that means X to Z has to be 11. Now it comes and says, hey, Z to X, the length from Z to X, the expression represents that as 2n minus 1. Well, you and I already know its length is what? 11. So 2n minus 1, that expression, has to obviously come out to equal 11. So we just set them equal to one another. When we solve it, well, let's do 2n minus 1 equaling 11. We add 1, we add 1. We get 2n is 12. Divide by 2, you're going to get n equals 6. And that's going to be the value of n. Now, we spent some time drawing these out. Some people may have looked at this and said, hey, I want to know z to x. And here's z to x. It told me that zx piece was 2n minus 1. Well, I know the z to x piece has to match up the length of whatever c to a is. So they knew right away that the 2n minus 1 had to match up with that 11. And they may have just set the equation up right away and then solved it and got n as 6. It's a little faster. But again, since we're beginning with these, we might want to draw out the pictures to make sure we're doing things correctly. There's problem 14.